we'll do a quick run through some derivatives, some shortcuts, and then we'll jump into continuity. Okay. So let's do maybe a square root function. So f of x equals square root of 1 minus 2x. This particular function is one I always put on the first test, something like it. Okay. Now this one, notice the inside of the function. What's the slope of the inside of the function?
-2.
Yeah, so that is something that's going to be related to the chain rule. When my interior function doesn't have a slope of 1, I'm gonna use that slope. That slope is changing my function, right? So like if I just looked at the square root of x, right? There it is. And if I looked at y equals square root of 2x, what it does is it kind of, here's square root of x again, but this guy crunches it down. If you remember the dilations and compressions and all of that, when I'm multiplying by something on the inside, it's compressing in the x direction. Okay. You can kind of see it lifting up, and that's me going, okay, that's square root of 2 times square root of x. So it's got an expansion in the y direction of square root of 2, 1.4 something. So it looks like it's stretching it up. It also looks like it's stretching it, compressing it, right? And we did all this in pre-cal, if you remember. Trying to get rid of that other red curve. I don't have to. It doesn't matter. You get the idea. So what I'm trying to say is, when I've got a multiple of my interior slope, it's changing the curve, right? So like at 1, I would have had this tangent line, but now at 1, I have this tangent line. You can see it's changing the slope at that particular point, right? And this is why the chain rule is difficult. Anyway, let's do this function. So I want f prime of x equals the square root of 1 minus 2 times minus the square root of 1 minus 2x all over h. Oh, that limit, right, as h goes to 0. Oh, that's the other thing I noticed on the homework is a lot of you are using the notation rule. Once you plug in, there's no more limit, right? And then if you're changing your interior function and in the same line as your limit, you got to keep the limit. And I'll put notes on everything when I grade it. So I need x plus h here. Everybody okay with this? I need f of x plus h, right? And I replace with empty parens minus f of x. There's my difference. All divided by h, there's my quotient, difference quotient. On this particular one, because it's so kind of messy, I like to work on the replacement functions separately, right? So I've got the square root of 1 minus 2x minus 2h. And when I can, morning, the coffee's really strong, so be careful. It's almost jet fuel. So you see here I'm working on that interior function, and when I do that, I like to get rid of my interior parenthesis. Not always. And how do I know? Same way you know what a difference between a cat and a dog is. People just told you enough times, right? Like my dad, I used to say, oh, look at that car. And he'd smack me and say, no, that's a truck, right? I got hit enough times guessing the wrong thing until I figured out the pattern, right? So same idea here. Do enough problems, right? And we're gonna multiply this by a conjugate, yes? What's telling me use a conjugate here?
We're dealing with roots.
Yep. And I always want to multiply by 1 or add 0. Nasty. But the upstairs, we know, is going to drop that middle term, right? So we know we're going to get 1 minus 2x minus 2h minus parenthesis, right? I got to be careful with those parentheses there. And you really should just not be copying me here. You should be just kind of motoring ahead. Everyone okay with that step?
Right.
I want to distribute upstairs, but I can see that the 1 will become negative, so I can kind of cheat that a little bit, and then the 2x will become positive, right? So I can, as much as I can cheat it, I will try and cheat it, but if I'm making mistakes, don't skip a step like this, right? So now I've got what? Minus 2h over h times that conjugate. Every time I write a new line, I want it to be a complete, what's that? Oh, every time I write a new line, I want it to be a complete sentence. I don't want to do just partial of the work. I want to write the whole sentence, right? So now the only thing I'm looking at is here. That's my complete sentence. That's my derivative so far. Or that's my replacement function, right? I don't have the limit on there. So now I see the h's cancel. And I just had a really strong cup of coffee, so you make sure I'm not going too fast. And the chat is open. This is finally my replacement function. You can see I'm not getting a 0 upstairs, right? You can see that I'm not getting a 0 upstairs. Jesse, I don't mind the camera off because you're active. So
Yeah, that's bedhead, extreme bedhead today.
that's why we have hats. Yeah, I got some going too. Okay. So there's my replacement function, right? So now I'm ready for my limit. So the derivative f prime of x is the limit as h goes to 0 of f of x, which turns out to be the limit as h goes to 0 of g of x, right? I don't feel like writing it again, and yes, you can do that. And that I can plug into. Notice when I'm plugging in, I'm no longer writing limit. And so I get negative 2 over square roots of 1 minus 2x plus another square root of 1 minus 2x, all of that sum in the denominator, and there's 2 of them. And you can kind of see my original derivative, 1 over 2 square roots of, and then times another negative 2. That was from that chain rule piece. But these 2's will cancel. And there's my f prime of x, minus 1 over square root of 1 minus 2x. How we do? Yes, I've seen a question.
If we had done the derivative rules we learned in the last class, at the very beginning, so if we use 1 minus 2x as a whole variable instead of just the 2x part, and then did 1/2 minus 1, would we only get the 1 over the root of 1 minus 2x and we wouldn't get the negative? So we would be right.
One more time.
If we use the derivative rule for the very beginning of
Oh, yes. Okay, I got you. So let me explain first. When I'm doing those shortcut rules, right? Mm-hmm. I'm talking about an interior function of x only.
Okay.
So the difference with this one is that, and I asked you to look at this first. Look at the interior function. It's not just x. Yeah. So this is chain rule, and this is why the chain rule in section 3.4 is difficult. Okay, because the shortcut rules. It's a little different. So here, let me do this. Let me say y equals square root of x, right? Y prime, we got 1 over 2 square roots of x, right? But on this one, where I have y equals square root of 1 minus 2x, I'm going to get y prime is 1 over 2 square roots of 1 minus 2x times a negative 2. That's my chain rule. I need to do multiply by the derivative of the interior function. So it's complicated, but our limit law, our limit definition will still work. Okay? Our limit definition will still work.
Thank you.
Yes. Let's do another one. Am I okay here? Can I do another one? Are we ready? Yep.
Yeah.
Good. Let's do a tangent line on this one. So let's say f of x is x minus x squared. And we want a tangent line at x equals 2. So we're going to, now on some of the homework I said, on some of the homework I said no shortcuts, right? So on this homework I said no shortcuts. So I'm asking you to 5 problems using getting the derivative the long way, right, with the limit, okay? Of course, you can, on some of them you can see the shortcut, right? And so you can double check yourself, of course. So so if y equals x, what's y prime?
1 minus 2x.
Just 1, right? And if y...
Oh, okay.
Yeah. Yep, if y equals negative x squared, what's y prime?
Negative 2x.
Negative 2x. Is everybody okay with that? The first one is a slope of 1. The second one is a power rule. I bring down the power and reduce the power, right? Is everybody there with me? Anybody not there with me? Nice. So let's do it with our limit, right? So first of all, I want to find f of x plus h. Now notice what I do. I write in x minus x squared. You see that? I write in x minus x squared with empty parens. And inside of each, I put x plus h. Right? And I'm doing this composition, right? You remember doing this in pre-cal, I'm sure. So I want to expand this out. And again, you're not copying me here. You're doing this work on your own because it's too easy. I'd rather you do it than copy. So I'm quiet because I'm just, oops, I made a mistake, plus h squared. So there's f of x plus h. Anybody get the same? Soon, yeah? Pedro? You got the same? Tally? Nice. Johan? Nice. Caroline?
I got the same.
Nice, thank you, Caitlin.
Yeah, that
Markin?
one's a gimme.
Markins, okay?
Yes, I'm okay. Like, my computer was shut down when
Oh,
I
no,
just got
no problem. No problem.
listened this.
No problem. I'm recording.
Okay, thank you.
So now I write f of x.
Yeah, excuse me.
Yes.
Excuse me, Professor.
Yes,
Can
yes.
you explain me like f dx equal x minus x squared? The first one on the third place.
Oh, that's just the function I chose.
Oh, okay.
That's
thank
the,
you.
and it's my total choice. What am I gonna pick for you? Some kind of. There's a couple. There's a tough one in the. But I'm gonna pick polynomial, fractions within fractions, radicals, right? So f of x is x minus x squared, and notice I'm putting the x here, and then the x squared here. I'm trying to line them up purposely because what's going to happen to those pieces that match? They're going to drop out when I do the difference part of the difference quotient. So now f of x plus h minus f of x is h minus 2hx minus h squared. The key here is, if you have anything without a factor of h, you made a mistake. The h's are going to have to cancel. If they don't, you're in trouble. Okay? So I'm dividing this by h, and I'm going to factor an h out. Make sure you're caught up with me here. Notice at this point I cannot plug in h. I'll get 0 over 0. But once I cancel my h's, right, I've got my difference quotient. I've got my g of x. How are we doing here? Nice.
How did x cancel x squared?
So here, x cancels with x, and x squared cancels with x squared.
Oh, my bad. Okay.
Yeah.
Oh, the original function. Okay.
Yes. And so I've got the limit of 1 minus 2x minus h, right, as h goes to 0, which is 1 minus 2x minus 0. I'm thinking that eventually you can stop putting that 0 in and just go right to the derivative, right? So there it is. So f prime of x is 1 minus 2x, which is what our shortcut said, right? Now, I picked something in the domain of the function, right? Which is everything, by the way. The domain of a polynomial is any x I can put in. So I picked 2, right? So I want to get the graph of the function, the x value at the point, the y value at the point, the slope at the point, and then the tangent line every time, right? So I know x is 2, right? F of 2 is 2 minus 2 squared, right? X minus x squared, which is 2 minus 4, which is negative 2, right? So the point is negative 2, negative 2. And what's my slope? It's f prime of 2, right? This is the key that you understand what the hell's going on here, is that this derivative tells me the slope at any point on the curve, right? So what do I get? I get 1 minus 2 times 2. 1 minus 4, it's negative 3. So I've got my point, right? The point is 2 comma negative 2. I've got my slope, and from there I get the equation of the tangent line. Don't let me go too fast here. I feel like I'm flying with the coffee. So everyone with me? Anybody need clarification on anything?
Yeah, sir, I have a question about
Yes,
this.
no. Go ahead.
So on the test, the question will probably look like find the equation of the tangent line at this point using derivatives.
Yep.
Yep.
And on the test, I will allow you to do a shortcut derivative most likely. Because if I want to
Just show how you're doing it.
no, if I just get the tangent line, right?
Oh, okay.
Yeah. So
So for f prime, why
Yes.
did you do 2 and not negative 2?
oh, because that's what I asked for originally, a tangent line at 2.
Okay, so you don't want the...
Right. I want the x. I want the input, not the output, not the height.
Okay.
Yep. Good. So equation of my line is y minus a negative 2 equals negative 3 all times the quantity of x minus 2. Y plus 2 equals negative 3x plus 6. Y equals negative 3x plus 4. Please make sure you get the same thing as me. Once I get a couple of confirmations there, don't just copy mine, do it yourself. And then we'll go to the graph it. And when you do these two, I think I have 2 problems like this in the homework for Monday. Give me a rough sketch, right?
Yeah. Professor, can you explain that again? Difference between x2 and x1. Just
Where are you? Let me give you numbers, okay? 1, 2, 3, 4, 5, 6, 7. What number are you on?
so number 4. So the difference between x2 and x1.
It's x1 and y1, right? This is a single point on the curve.
Oh,
right?
is that the output of the derivative?
Yeah, of the function.
Okay.
Right here. So 2 was my input. So I'm drawing a tangent line at x is 2, y is -2. It'll be a little bit clearer when you see it on my graph. Oops, I keep doing that. Stop doing that, Robert. So just let me launch a Desmos here. And I just want to make sure I have a couple of confirms on the tangent line. Thumbs up is fine, nod is fine. Yes, thank you. Thank you. So I had y equals x minus x squared is my function. I had the point 2, -2. It's always nice to see that I've got at least the right point on the curve. It's also nice to see that I know I'm going to get a negative slope, which I did, right? I got a -3 as my slope. So my tangent line is y equals, I forget already, is it -3x plus 4? Boom. Love it. See, it's usually, I argue with my girlfriend all the time. I'm never right, right? So, so I'll just go and do some math, and then I know I can be right every now and then. I'm not always right, even in math, but she says all the time to me, "You got problems." I said, "Oh yeah, number 37 in section." So the graph is going to be a key for you on the test to know you have this correct, right? So even if I don't ask you to graph a tangent line on the curve, you can double check yourself. All you have to do is pick a point in the domain and then graph the function, graph the tangent line. It should make sense. It gives you confidence that you have it right. How are we doing? So for sure, you can do 5 of the 7 homeworks, for sure, guaranteed. In fact, let me just take the continuity off of there, just because I don't feel like I'm going to get it done today. So I had originally said, and I didn't put it on Blackboard yet, right? So, but I'm going to take out these 2 problems. So next Monday, only the problems that we just finished with today. And I'm going to put this on Blackboard. I'm going to send out an announcement, right? And please fix the mistakes from homework 1. 1 problem per page, name on every page, single PDF. Okay? You might have to rewrite a homework problem every now and then. Like I would do it the first time quickly, right? And then I might take 3 pages to do it. Like one of them is really long in this homework, and then rewrite it to make it look pretty and fit on a page and etc. You know. I think that's pretty reasonable, right? And you could do them all now. I think one of them is difficult, so let's look at 1 problem real quick, and then I'll move on to continuity. Probably not going to finish continuity till Wednesday, but that's fine. I don't care. I don't want to rush through things. I don't need to. So one particular homework problem, I think it's number 27 and 2.7. So this is 2.7, number 27-ish. Right? It's like it. But I'm going to have a function that's a rational function. Okay? And we'll look at one that we actually know the answer of already. x over 1 plus x, right? If you remember, we did this one in homework 2.1 number 5. Oh, no, 2.1 number 3 from WebAssign. But it doesn't matter. I did it in class. But I want to find the derivative of this. And we found that derivative at a specific point, right? With a secant slope, and then we found the tangent slope. But you're going to do this one with the limit now. So f prime of x, just to set it up, is the limit as h goes to 0 of x plus h, or better yet, x over 1 plus x, right? You can see the original function there with empty parens minus the original function, all divided by h. And what am I putting in there? An x plus h. Kind of nasty looking. This is probably the most difficult problem in your homework. And not because it's difficult, because it just takes a little patience. You want to go nice and slow. You want to kill as many trees as you can. Don't start squeezing things in to save paper. After you get a job, as a famous surgeon or whatever you're going to be, builder, go plant a couple trees to make up for all the paper you wasted in Calc 1 and Calc 2 and diffie-qs and linear.
So this one's going to be, look at the internal denominators.
Exactly. So
Okay.
in this particular one, I like to clear all my parentheses first, and then multi-term, put parentheses back. And what's my LCD here? Interior.
Is it 1 plus x?
So far?
1 plus x plus h.
Yes. All over itself. 1 plus x times 1 plus x plus h. First time I do this, I would say, oh, by the way, if you get 100 on a test, I'll send you a nerd pen. One of those pens with the 4 color clickers.
Those are neat.
If you already have one, by the way, you could be a nerd already. So, but it's nice to do this original in black, right? Original in black. And then distributing through with to all the numerators with your other color, with another color. So I'll use the purple here. So I'm really taking my time here, right? Trying to really do baby steps along the way so that I also don't want to be inside of my head. One, because it's dangerous in there. If you had my life. And then the other is because I can't grade, you can't hand it in, right? I can't see what you're doing in your head. I want to see it all on paper. And then I'm ready to cancel a couple of things. Oops. So the 1 plus x plus h goes, the 1 plus x goes, and then I'm rewriting nice and slow. Taking my time. Not trying to do too much. Double checking everything as I go. Oops. I'm just going too fast. There's plenty of time for you on the test. 10 problems in an hour and 25 minutes, right? 10 problems in an hour and 25 minutes. Right, what's that? 85 minutes divided by 8.5 minutes per problem. Lots of time on your test. I don't want to finish. You know what to do. You're going to distribute everything upstairs. Cancel like terms, right? Cancel terms where they can. Make sure there's only h's left upstairs, and then go do your limit, right? So you can see this one could take a couple pages easily. We will have some problems later that will take 3 to 5 pages for sure. Questions for me? Four, 8, 12, 16, 20. Missing 4 students today. What do you think so far? How are we doing? Nice.
Tell us what the derivative function is.
Well, I'll do the quotient rule to get it. F prime G,
Yeah.
G prime X, 1 plus X. This is a 1, this is a 1. Quotient rule is, so F prime is 1 plus X minus X all over 1 plus X squared. So F prime of X is 1 over 1 plus X quantity squared. And if you remember, when we did this problem in class in 2.1, we had to find the slope at 1, right? So F prime of 1 is 1 over 1 plus 1 quantity squared, and there is our 1/4. Say again, Marcus?
Equal to first, but now.
Oh, no, I did the quotient rule. This is section 3.2. But Jesse asked me what's the, I didn't feel like doing the rest of this algebra. That's your job. So I did. I took a
This is the shortcut.
Exactly.
Oh, okay.
I don't know why. I think I got something wrong there, but oh yeah. No. I don't remember. There's some. I did it too quick. You'll either get positive 1/4 or negative 1/4. I don't remember which one. I think it was positive 1/4. I'm trying to look at that graph again. Yeah, it was positive 1/4. That's right. At 1, but remember, we're doing a derivative. We're doing the slope at any point, not a specific point.
Professor, is the goal to cancel out the variables without h on the numerator?
Exactly.
Or is it on
Exactly. Exactly. All of the non-h terms should go away. Some h terms could go away, but the non-h terms should all go away, so that I could factor out an h, and that h will cancel with the downstairs. If I don't do that, something went wrong. You did some algebra wrong. Okay.
Ideally, you're left with 1x on the top or the bottom, and no h is left over.
Once you cancel.
Yeah, once you cancel.
Yes. Okay, cool. Let's talk about continuity. So I don't have much time here, but I would like you starting to read section 2.4. Which is all about continuity. To be continuous, right? When is a graph continuous? And it's obvious, right?
It has a few rules, but you can put at your finger along the line at any point, and there's no hole.
Perfect.
And, yeah.
Perfect. No holes. That's the easiest thing to think about it. No holes. So that means no gaps, right? Gaps are worse than holes, right? Right. So that case where I took the manhole cover off, I still have a limit, right? But it's not continuous. Yes, you with me? So we want to make sure that everything gets filled in. Everything gets filled in. We want to take that manhole cover and put it back on, right? Why are manhole covers round? Anybody know? Anybody know why manhole covers round? Not
Why they're round? I have no idea why they are round.
I think it's the lightest. You can make a circle.
It's the simplest shape I can make that it won't fall in on itself. Like if I made it a square and then turned it on the diagonal, the top would fall into the hole. So the circle, right, is always the same width everywhere. It will never fall into that hole onto the people that are working.
And it doesn't waste metal. Yeah.
Yeah, I know what you're trying to say. You're trying to maximize the area, minimize the surface area. Yeah. Kind of. It's the secret on that one is the hexagon. The hexagon is the best for that. The bees told us that to maximize the surface area and minimize the perimeter. So when is a graph continuous? It's obviously no holes, right? So what's going to be true about this? No replacement function is needed. Needed for the limit, right? It'll serve as its own replacement function, meaning I can do what with the x value? What can I do with the x value right away?
Or put it over itself, or
nope, don't even less than that, even simpler than that. Plug it in, exactly. So since this thing doesn't need a replacement function, I should be able to find the limit by plugging it in, and that's the key to our definition, right? So definition of continuity. The limit as x goes to c of f of x is f of c, and that number is real. This is the quickest way for me to say it. So the limit itself is a real number. It can't be infinity, right? And you can see I can just plug in the c. I can plug in the c right away. So I better be able to demonstrate three things. To verify continuity, show the following. And there's some good problems to do here in the book. I think I have a couple in WebAssign, but you should, the one that says the following functions are discontinuous, tell me why. You should go through this 3 process, and I'll do a couple today, but or more Wednesday. But I should be able to show that f of c exists. Right? So plug in right away and make sure you get a number, right? Show that the limit exists. F of c exists, the limit exists. That means you might have to check left and right, right? And step 3, show 1 is equal to 2. Show they're the same number. Because I could have f of c different than the limit, right? And then that means the manhole covers off of the road, right?
So if we can't plug in right away, then it's not...
Exactly. That's why we check that one first, because it's the easiest. If you plug in and you get a 0 over 0, or you get infinity, right? Some number over 0.
Knowing that, almost all the ones in the test are just gonna be discontinuous.
I'm not going to give you. You'll see the type of problem I'm giving you are like in section 2.4, number 33 and number 35. So, but But you should still go through this process on your own of showing
Yeah,
something
it's
that's
still
discontinuous.
helpful.
Yes.
Because you need to know from looking at certain graphs.
Yeah, and graphing it would definitely be helpful. Sometimes you can make the graph and you won't see. On my graphs, you will see for sure. But I'm more interested in making things continuous than I am having discontinuities. So if I have a limit, I may or may not have continuity. You agree with that? Limits don't imply continuity. Right? You agree with me? Because remember, in a limit, I don't have to go all the way to C. Right?
Because
So
you can also have ones where the two different types of limits are different.
Exactly.
You can find them two different ones, and one will be positive infinity, one will be negative infinity, or one is 1 and one is negative.
That's right. Continuity does not imply differentiability. Just because I'm continuous doesn't mean I have a perfect slope at that point, right? And so the picture of the first one is, right, I've got some manhole cover taken off the curve, right? And my differentiability piece, I'll look at the absolute value of x. I'm continuous at that point, but I don't have the same slope at that point, left and right. Do you see that? So I'm learning about limits, and then I'm going to make it even better by forcing it to be continuous. And then if I have something continuous, I can stand on the hill, but maybe I can't. Maybe I'm teetering, right? I'm teetering on the hill with my skis, so I can't really measure the slope. So then I want to make my continuous functions differentiable. And so this is really what we're going for. If I can get a derivative, I definitely have continuity, and I definitely will have a limit. So it doesn't, I don't have these implications starting with the limit to continuity to differentiability, but the reverse I do. If I'm differentiable, then I definitely can get the slope, and I can stand on the hill, which means I can if I'm continuous, there's no hole there. I'm not falling through the hill. And certainly I can figure out the height, the limit. This is a little bit super nerd here that I'm talking about, right? So it's not that essential.
So
go ahead.
Something like f of x is the apps value of x. It's not differentiable.
Correct.
Because the rules of absolute values. Okay.
Yeah, and you could actually see me standing on this hill on my skis, right? And I'm
well, I actually have forbidden knowledge. It is differentiable, but only if you go in the imaginary plane. We're not there yet.
We're not going there. We're not.
Yeah,
That's a completely different branch of mathematics.
Yep.
And still not differentiable.
Okay.
Even in the complex plane, there's a positive slope on one side and a negative slope on the other.
I see. Okay.
Okay, so there's only a few types of problems to do. But we only have about 10 minutes left, so I'll do what I can real quick here. So problem types show continuous or not, right? And then step 2, find the connector function, I'll say. So let's see if we can do one of each real quickly here in the time we have left. And so this, by the way, is homework 5. This is so don't worry about starting that yet, please. Don't worry about doing that. Focus on those derivatives. Get a bunch of those derivative homeworks done. The derivative homework is homework 6, so I went out of order, but God, sorry about that. Sometimes it happens. Sometimes a road is closed and you got to find another way home. So homework 5 is continuity, so wait on that. Certainly start reading chapter 2-4, okay? So let's start with a nice simple function. Something like e to the x and ln of x. And we'll do this one for x is greater than or equal to 1, and then this one for else. Or better yet, x less than 1. Now, we should be able to do these a couple of ways. We should be able to do them with limits, and we should be able to do them graphically, right? These particular functions are pretty easy to graph. You should have them memorized from pre-cal, right? This is y equals ln of x. This is y equals e to the x. And it's pretty clear, right? It's pretty clear that we're talking about something discontinuous here, right? So what I like to do is write my function in again, just with the piece that I need. And then it's easy on my particular tablet because I can erase things pretty quickly. There's a nice way to do this on Desmos, and there's a nice way to do it on your calculator as well, to graph a piecewise function. So for your calculators, look up graphing a piecewise function on a TI-84, whatever you're using, right? For Desmos, I just use a curly bracket. I think it's a curly bracket. Y equals e to the x. Curly bracket, x greater than 0, x greater than 1. Oh, less than 1, right? Sorry. Oops. Right, so just in parentheses the domain right after the function, right? And then the other one, what was it? Y equals ln of x for x greater than or equal to, down in the keyboard. No, down in the math palette, I have a greater than or equal to 1 there. Now you can't really tell less than or equal to 1, greater than or equal to 1, but because my domain at 1 is on the ln function, I know that 0.10 is in there, right? And of course, you see what I put on mine. I put in the empty point where the domain is missing, right on the e to the x function, and the filled in point for the ln. So what's f of 1? That's ln of 1, right? So that's a real number. Good. I need the limit to exist when I plug directly in. Sorry, the value to be in, and I need it to be a real number. What's the limit as x goes to 1 from the left? Well, I'm going to use e to the x, right? And that's e to the 1. And the limit as x goes to 1 from the right, and that's ln of x, which is ln of 1, which is 0. So the limit doesn't exist, so it's not continuous. So the limit as x goes to 1 of f of x does not exist, and f is not continuous. So use the checklist, right? And there's a bunch of problems in the textbook in there. A bunch of problems where it says show the following is not continuous. It's going to fail somewhere along the line. Step 1, You can't plug in. Step 2, the limit doesn't exist. Step 3, they don't match, right? One of those steps will fail.
So basically we used the connecting function, which in this case is 1, and if they're not equal, then it's not continued.
Right. And again, you're asking, okay, does the value of the function exist? Does the limit exist? Do they match? Right? Simple process. Do it in order. Right? Do them in order, and it'll make your life a lot easier. All right. I don't want to do any more today. So have a great day. Get started on the homework. Start looking at the Chapter 2 review. Look at my old quizzes in Chapter 2. Start looking at the Chapter 2 tests. We're almost there. What did I have down for my test? What did I say about the test? I thought I said it somewhere. Oh, yeah.
Is it up 25th of February?
Yeah, I think it's the last Friday of Feb. Yeah.
Okay.
Yeah. Is that Tal? You reading that on the schedule? Because what I have.
No, I remember you saying
Yeah,
that.
yeah. I'm pretty sure that's what it's on the schedule, and I'm not going to move it. I like to, for you to be getting ready, right? Like, okay, I have a doctor's appointment in a month. Let me not eat French fries. So when they check my cholesterol, well, you probably all don't check your cholesterol yet, but wait till you get old. Yeah, so you cheat the doctor. So I'm thinking, okay, you have to get up at 8 that morning. It's hard for you to be getting up at 8. You're probably going to even get up earlier. So you start practicing getting up at 6:30 before that test.
Professor, on the test, do you value work a lot?
Yes, partial credit. I give partial credit. Yeah. The only way to get 0 points is to leave it blank, or just write the question over, or just give me a picture of an angry fish, something like that. Something arbitrary.
Professor, do you know the date of the second test?
I'm pretty sure it's right before spring break.
Okay.
And so that probably is 2 weeks after the first test.
Okay.
Because I'll have taught half of Chapter 3 before the first test, and which is all derivatives, by the way. It's all derivatives, so it's not going to hurt anything.
Okay.
All right. Have a great day. I'll see you Wednesday.
Thanks, Professor.